Today, in this video, I'm going to start the fourth chapter, that is moving charges and magnetism. So the first topic in this chapter is magnetic field. This is not a new topic for you all, as the topic magnetic field was studied in class 10th also. So the definition remains the same, that what is magnetic field. The magnetic field is the area around a magnet in which there is magnetic force. Now what do you mean by magnetic force? The area around magnet till where its influence can be felt. We all know that if we bring a iron nail near a magnet, what will happen? We will experience some force. That force can be either repulsive or attractive. If you bring a iron nail near a magnet, you will experience a force. Now suppose you are moving iron nail away from that magnet. Okay, you are moving that iron nail away from magnet. The force which you were experiencing would be reducing. Its magnitude would be reducing because you are moving away from it. There would be a certain point where you will not experience any single force. That means there is no influence of that magnet on iron nail because you have crossed the magnetic field. So every magnet has a certain magnetic field around it till where you can feel its influence. So that influencing area around a magnet is called magnetic field. So this is what magnetic field means. The word magnetism and electricity are very closely related to each other. There was a scientist, Hans Christian Ørsted. He discovered that electric current can produce magnetism. What he did, he took a wire, he passed electric current through it, he placed a magnetic compass near that circuit, and what he observed, that there was deflection in magnetic compass, and magnetic compass can only be deflected in the influence of magnetic field. Now what was the conclusion? That a current carrying wire or electric current has a magnetic field surrounding it. So wherever there is electric current flowing, there is a certain magnetic field around that wire. So an electric current, that is flow of electric charges, because flow of electric charges make electric current, and electric current produces magnetic effect in the space around the conductor called magnetic field. Now this was the Ørsted experiment, when current was allowed to flow through a wire placed parallel to the axis of magnetic needle kept directly below the wire. The needle was found to deflect from its normal position. When current was reversed through the wire, the needle was found to deflect in the opposite direction to the earlier case. So this was the experiment which was called Ørsted experiment, which proved that magnetic field can be produced by electric field. Now see, Ørsted did told that electric field can produce magnetic field, but he was not able to tell that how much magnetic field that electric current can produce. Now this was being told by Biot. Now there were two scientists, Biot and Savart, which both gave this law, Biot-Savart law. Now he told that what would be the value of magnetic field at a certain point due to a small length element in which current is flowing. So suppose this is the wire in which current is flowing. Let its length be dl. dl is the length of that small current element. I is the current flowing through it. P is the point which is at distance r from this length element, at which you want to find the value of magnetic field, because when the current is flowing through a wire, there is a certain magnetic field around it, right? So this law told the value of that magnetic field. Now theta is the angle between the current element and the axis of that point. Now Biot-Savart's law, the strength of magnetic field due to current element dl depends on the value of current. The first point was that magnetic field is directly proportional to the current flowing through the wire, that is dB. dB means small magnetic field, because small element would be having a small magnetic field, that is dB. So dB is proportional to I. Second point was that small magnetic field due to that small element would be directly proportional to dl. dl is the length. More the length of that element, more would be the magnetic field. Third, dB is directly proportional to sine theta. And fourth was dB is inversely proportional to square of distance. More the distance, lesser would be the value of magnetic field. Now if you combine all these 4 points, what you get? dB is proportional to I dl sine theta divided by r square. On removing the proportionality sign, you get a constant k. Now the value of k here is mu naught divided by 4 pi. Now if you put the value over here, what you get? dB is equal to mu naught divided by 4 pi I dl sine theta by r square. Now mu naught means permeability of free space. Like in electrostatics there was epsilon naught, that was permittivity of free space. So here mu naught is permeability of free space, and its value is 4 pi multiplied by 10 to the power minus 7 Tesla ampere inverse meter. So the mathematical form of Biot-Savart's law would be dB is equal to mu naught by 4 pi ideal sine theta by r square. So this would be the mathematical form of Biot-Savart's law, where mu naught is permeability of free space. It means that the property of material to ensure that how much magnetic lines can pass through it. That is the permeability of any medium, that how many magnetic lines can pass through it. So it is just like electric permittivity, that was in electrostatics, that was epsilon naught. Here we have mu naught, permeability.